Hello everyone, welcome first year students, English section, Faculty of Commerce, Sadat City University. It's me, Reem Sobhi. I am a teaching assistant at Insurance Statistics and Mathematics Department. I will be with you in the sections of Pure Mathematics course. Today, in our first section, we are going to discuss Chapter 1 titled Relations and Functions. In this chapter, we hope to learn some objectives such as what do we mean by relations? What are the types of relations that can be defined in? Also, what do we mean by functions as a special case from relations? First, let's start with relations. What do we mean by relations? Relations can be defined as a correspondence between two sets, where each element in the first set, called domain, corresponds to at least one element in the second set, which is called the range. Also, relations can be defined in another form as any set of ordered pairs. The set of first components in the ordered pairs is called the domain of the relation, and the set of the second components in the ordered pairs is called the range of the relation. The relation can be defined in four different forms. The first form as a correspondence between two sets, or it can be defined in an ordered pairs, or can be defined in graphs, or can be defined in equations. Let's have an example. Express the relation between x and y by ordered pairs and correspondence, then find the domain and the range of the relation linking the variables. In this example, we have two variables, which is x and y, and we have here the values of x and the values of y. In this example, he needs to express the relation between x and y in two different forms, which are ordered pairs and correspondence. Let's see how we can represent or express these relations. Let's first represent the relation in a correspondence form. In this form, we put all the values of x in a set called a domain and all values of y in a second set called a range. So the first form is the correspondence. The values of x are the domain of the relation, which are 0, -2, and 5, -7, -2, and 5. And the values of y would be the range of the relation, which are 3, half, 10, 1, 8, and 1. Each value in the domain should correspond to an element in the range. So we can call these a relation. So 0 corresponds to 3, and -2 corresponds to half, 5 corresponds to 10, -7 corresponds to 1, and -2 corresponds to 8, 5 corresponds to 1. And as you see here, each element in the domain corresponds to an element in the range. So we can say this is a relation. The second form is ordered pairs. In this form of the relation, we group all values, each value of x or each value in the domain with the correspondent value in range. So the relation would be the first pair will be the value of an x in the domain, which is 0, and the correspondent value in a range, which is 3. The second pair would be -2 and The third pair, 5 and 10. The fourth one, -7 and 1. -2 and 8. 5 and 1. So this is the shape or the form of the ordered pairs. The first pair here consists of two components. The first component is the value of x, and the second component is the value of y. Also, the first component is 0, or the value of x, can be called the domain, and the second component of the pair, which is the value of y, can be called the range. So if we need the domain of this relation, we can say that the domain equals 0, -2, 5, -7, -2, and 5, which are all the values of x. And the range of the relation would be all the values of y, which are 3, half, 10, 1, 8, and 1. So we represented the relation between the two variables x and y, first in a correspondence form and second in an ordered pairs. Another example here, choose the correct answer. Determine if the following is function but not relation, not relation not function, relation not function, relation and function. Functions are a special case of relations. Functions is a correspondence between two sets. The first set is domain and the second set is range. But each element in the domain should correspond to only exactly one element in the range. If any element in the domain corresponds or coordinates with more than one element, so this is not a function. In this example here, the first set is months, October, January, April, and the temperature. So this is the domain of the relation, and this is the range of the relation. Each element in the relation corresponds here to only one element in the range, or exactly one element to the range. And each element in the domain corresponds to an element in the range. So this is a relation because each element in the domain corresponds to elements in the range. And this is a function also because each element in the domain corresponds to only or exactly one element in the range. So this is a relation and a function. And the correct answer is D. Example 2. Determine if the following is function, not relation, not relation, not function, relation, not function, relation, and function. We have a relation here between persons and their phone numbers. We can call the set of the person's name as domain, and we can call the phone number set as range. We can say this is a relation if each element in the domain corresponds or coordinates with an element in the range. And as you see here, each element or each person here in the domain has a phone number in the range. So this is a relation. For the function, If each element in the domain or in this relation corresponds to exactly one element in the range, we can say that this is a function. And here in this relation, each element in the domain corresponds only to one element in the range, so this is also a function. So the right answer is also D, and this is a relation and a function. Example 3. Determine if the following is function not relation, not relation not function, relation not function, relation and function. We have here the start time for significant sport and in the first set, and we can call this set as domain. And the second set is the sports, and we can call this set as the range. Here in this example, we can say this is a relation or not if each element in the domain corresponds to an element in the range, so this is a relation. And here, each start time in the domain has or corresponds with a sport, so this is a relation. But this relation is not function because the start time 1 p.m. corresponds or coordinates with two elements in the range, and this is not a function because we said that each element in the domain should correspond to at least exactly one element in the range. But here the start time 1 p.m. corresponds to two sports, football and basketball, at the same time, so this is not a function. This is a relation but not function. So the correct answer is C. This is a relation but not function. Another example, determine if the following is function not relation, not relation not function, relation not function, relation and function. The first set here we have the person's name, and we can call this set as a domain. And the second set we have the math score, and we can call this set as the range. We would like to know if this is a relation or not, and as we just said, the relation can be if each element in the domain corresponds to at least one element in the range. And here each person in the domain corresponds to one element, or each person has a math score in the range. So this is a relation. This is true. And if the second question, is this relation is a function or not? We said also the function in the function, each element in the domain should correspond to exactly one element in the range. And in this relation, each element in the domain or each person has a math score in the range or corresponds to exactly one element in the range. So this is also a function. So this example is a relation and a function, and the correct answer would be D. Example 5, determine if the following is a relation and function or not. At the first set, we can the course grades, and we can say it's the domain. And the second set, the range, are the person names. The first set here, each element in the domain corresponds to more than one element, because the grade A goes to or corresponds to Carrie and Shan, and grade B corresponds to Michelle and Jennifer. So this is a relation because each element in the domain corresponds to at least one element in the range, but this is not a function because A and B corresponds to more than one element in the range, so the correct answer would be C, because this is a relation but not a function. In example 6, determine if the following is function not relation, not relation not function, relation not function, relation and function. As we said before, again, this would be a relation if each element in the domain corresponds to at least one element in the range, and this is applied here, so this is a relation. This is a function or not? We can say that if each element in the domain corresponds only to one element in range. As we see here, 0, the first value of the domain, corresponds to -3, and also the 0 repeated here but corresponds to 3, so 0 goes to -3 and 3, also -3 and 3. So we can say that this is a relation but not a function, because there is an element in the domain which is 0 corresponds to more than one element in the range. So this is a relation, not function, and the correct answer would be C. Example 7, determine if the following is function not relation, not relation not function, relation not function, relation and function. This is a relation because each element in the domain corresponds to an element in the range. So this is a relation. The second question, is this a function or not? We go to the first elements in the relation, or which are the domain. If any element is repeated or corresponds with more than an element in the range, so this wouldn't be a function. And as we see here, 4 and 9 is repeated. 4 goes with or corresponds with -2 and 2, and 9 corresponds to -3 and 3. So this is not a function. This is a relation but not function, because there is some elements in the domain corresponds to more than one element in the range. So the correct answer would be C, relation not function. Another example, determine if the following is function not relation, not relation not function, relation not function, relation and function. This is a relation in an ordered pairs form. But is this a function? We can see by looking for the values of the domain. There is no value is repeated or corresponds with more than one element in the range. So this is a function. This is a relation and a function, and the correct answer is D. Determine if the following is relation and function or not. This is a relation, and by going to the first component of the pairs or of the set, we can see that the element 2 in the domain corresponds to two values in the range, which are -2 and 2, and 5 goes to or corresponds to two elements in the range, which are -5 and 5. So this is a relation but not function, and the correct answer is C. Example 10, also determine if this a relation and function. This is of course a relation in an ordered pairs, and is this a function or not? By looking for the domain values, there is no repeated values, or there is no repeated values, which means that there is no values or elements in the domain corresponds to more than one element in the range. So this is a relation and a function, and the correct answer is D. Example 11, Also determine if this relation and function or not. This is of course a relation in an ordered pairs. Is this a function or not? As we just said, we are going to the first element in the pair or the domain. If any element is repeated or corresponds to more than one element, this is wouldn't be a function. And there is no elements repeated here in the domain, so this is also a function, and this is a relation and function, and the right or the correct answer would be D. Question 12. Determine if the following is a function or not. This form here is the third form of the relation, which is equation. We just mentioned two types of the relation that can be defined in, which are correspondence and ordered pairs. This is the third form of the relation, which is equation. And to determine if this relation is a function or not, we have to assume some values for x and substitute these values in this equation to get the values of the y or the range. And if each value of x coordinates or corresponds to only one element in the range, so this is a function. Let's see here. First, let's assume some values of x. For example, -2, 0, and 2, and substitute these values in the equation to get the value of the y, which is x power 3. By substituting the value of x, which is -2, in the equation, we get the value of y, which is -8. And by substituting 0, we get 0, 2, we get 8. So here each value of x or each element in the domain corresponds to only one value in the range or one value of y. So this is a function, and the correct answer here is D. This is a relation and function. Example 13. Determine if the following is a relation and function or not. To simplify this equation, we have to take the square root for this equation. So the square root of x square plus y square equals square root of 9. And the equation will be x plus y equals plus or minus 3. And then y equals plus or minus 3 minus x. By assuming some values of x, if x equals -2, then y would be two values, 3 plus 2 and 3 minus 2, -3 minus 2. So 3 plus 2 equals 5, and -3 plus 2 equals -1. So if x equals -2, the value of y would be 5 and -2. So -2 and 5, and also -2 and -1. And in here, the value of x, or which is -2 in the domain, corresponds to two elements, which are 5 and -2. So this is not a function. This is a relation but not function, because in any value of x assumed would correspond to two values in y or in the range. So the correct answer would be C. This is a relation but not function. Thank you for watching this video and sharing your time with us. Hope it's useful to you. See you at the part 2 from this section, and good luck to you all.